Hello again, everybody. Welcome to the second part of the PowerPoint or the video for section 3.6, continuing on with our study of the chain rule and some different ways to use it. Okay, so here we have a problem. We're given g of x equals 3x to the cubed, 3x cubed plus 2 to the third power times 2x squared minus 1, that whole thing squared. We need to find g prime, so we have to find the derivative here. Now, hopefully you notice when looking at this, there's a couple of different things going on. So first of all, we have two functions being multiplied, which means we're going to have to use the product rule. But also notice that each of those functions we have is also a composite function, right? We have a function within a function. So we're going to have to use the chain rule as well. So here's what I'm going to do first on this one. I'm going to give each of these functions here a name, but not with that. There we go. So I'm going to call this one here h of x, and this one here f of x. And I'm first going to find their derivatives individually. So if I want to find h prime, well, notice, okay, I have a function within a function here. So I'm going to have to use the chain rule. And I'm going to skip a couple of steps in doing this based on what we've done in the past. But you can go back and work it out the way we've done before. But I believe if I use the chain rule here, I'll end up with 3 times 3x cubed plus 2 to the second times 9x squared. So I kind of did the derivative of the outside times the derivative of the inside there. And I think if I simplify that out, I end up with 27x squared times 3x cubed plus 2 squared, like that. Okay, and then I'll also find f prime. If I do that again using the chain rule, looks like I have 2 times 2x squared minus 1 to the first power times the derivative of the inside, which would be 4x. Multiply that out, we'll have 8x times 2x squared minus 1, which I think I can distribute that 8x there. If I do that, I will end up with, I'm going to write it over here, 16x to the third minus 8x. Okay, so these two things here are derivatives. So now, we have the derivative of both h and f. Let's find the derivative of the function g. And remember, if we're using the product rule here, because we have two functions being multiplied, so we'll do the first function, so 3x cubed plus 2 to the third times the derivative of the second function, times f prime, which we found to be 8x times, or sorry, not 8, that. We simplified that to be 16x cubed minus 8x plus, then we're going to do the second function, so 2x squared minus 1 squared times the derivative of the second, which is 27x squared times 3x cubed plus 2 squared. Okay, and I'm going to erase some stuff here just so I can write this all out as one. This function is really kind of nasty looking, so we're not going to do a whole lot of simplifying here because it'll just get ridiculous after a while. But I think if we write everything out, so g prime of x, we can write as 3x cubed plus 2 cubed times 16x cubed minus 8x plus, and then we could write this as 27x squared times 2x squared minus 1 squared times 3x cubed plus 2 cubed. Sorry, that should be squared, huh? All right, isn't that a fun looking derivative there? I think so. All right, so that's the derivative. So again, we had to use a combination of both the product rule and the chain rule. And even though we used both on this problem, I do want to point out again the differences between the two. We use the product rule and we have two functions being multiplied. We use the chain rule and we have a function within a function, right? Okay, so let's use this now to find the equation of a tangent line to this function, which x equals 1. And in order to do that, there are a couple of things we have to do. First of all, we need to input 1 into the function g. Okay, so we need to do g of 1. And when we do that, let's see, I think we'll get 5 cubed times 1 squared. So I think it's 125 we get as our output. Yeah. Okay. And we also need to evaluate our derivative at that point. And I believe you guys can double check my math, but I'm not going to work it all out here. I believe if we do that, we get 1675. And remember, our derivative evaluated at this point, that gives us our slope, right? So that's going to be the slope of our tangent line. And to find the equation of a tangent line, or any line really, we need a slope, and then we need a point, which we have here. So we can put this into our y equals mx plus b, or f of x equals mx plus b. Plug in the information we have, so we would have 125 equals 1675 times 1 plus b. You can solve for b here. And if you do that, you'll end up with negative 1550. So then our equation of our line would be y equals 1675x minus 1550 or 1550. Okay, and that's our answer right there. Good times, right? Good times. Okay, let's look at doing the chain rule now in a little bit more theoretical example. So notice up here we're given that a function f is defined as g of h of x. And they want us to evaluate the derivative of f at a few different values. Now, before we do that, let's first write out in symbols what the derivative would look like. And here we can just kind of use our formula for the chain rule, right? So it tells us that we have an outside function named g. So our derivative should have g prime evaluated the function h of x times the derivative of h, right? So if you want to find f prime of 4, as we have here, well, that means in our little formula down here, we're going to replace everywhere we see an x with a 4. Should be a 4 here, not like that though. Okay, so we have a 4 here, 4 here, and a 4 here. Okay. So we'll start by evaluating at h of 4. Because we start on the inside there. So if we look at h of 4 over here, it looks like the output there is 3. But then that 3 now becomes the input for g prime. So this part right here now is g prime of 3, which we'll look over here at the function g. G prime means find the slope of the tangent line. Well, because this thing is already a line itself, we can get the slope by just looking at the slope of the line, which looks like it's 1. So our f prime is going to be 1 times. And we also do h prime of 4, which looking at our graph over here on the right for h, again, to find the derivative at 4, when you use just the slope of the line, since it's a linear equation, looks like we can go down 2 over 1. So our slope is negative 2. So here we get that f prime of 4 is negative 2. Okay? So that would be the first one. Right, so let's do the second one then. So now we do f prime of 1, which means in our formula here, we have to replace everywhere where there was an x with a 1. So we'll put f prime of 1, which is g prime of h of 1, which is h prime of 1. So we'll start by finding h of 1, which over here looks like h prime, or excuse me, h of 1 is 1. So then this becomes g prime sorry, hitting the wrong buttons here. Here we go. G prime of 1, which if we look over here again, the slope at that point looks like it's going to be 1. So our f prime of 1 is going to be 1 times. And then h prime of 1, look at the slope over here at 1. Looks like that one is up 2 over 1. So we do 1 times 2, which gives us a positive 2 for the slope there. Okay, or for the value of our derivative. Good stuff, right? Okay, I'm going to leave it at you guys to find f prime of 3. And I'll tell you right now, I believe that one comes out to be D and E. So I'll leave it out to you to figure out why that is. Okay, let's do a little bit more of a theoretical version of this. So here they tell us that we have this function capital F, which is given by lowercase f of x to the 4th. So see there, we do have a composition of functions, right? We have the function x to the 4th on the inside of a function f, but we're not told the formula for f. And we also have a function capital G, which is given by now the function f of x raised to the 4th power. So here is also a composition of functions, but in this case, f of x is on the inside, and then the thing raised to the 4th is the outside function. And they give us some other information. A cubed is 2, f of a equals 2, f prime of a equals 15, and f prime of a to the 4th equals 11. And they want us to find these things. So the first thing is f prime of a. So they want us to evaluate the derivative of capital F. Now before we do that, first thing we need to do is find the derivative of capital F. Okay, and we see again that this is a composition of functions, which means we need to do the derivative of the outside function, which is f prime, evaluated at x to the 4th, which is the inside function, times the derivative of the inside function, which would be 4x cubed, right? Because derivative of x to the 4th is 4x cubed. Now we can evaluate that at a, so do f prime of a, so we get f prime of, now instead of x to the 4th, it'll be a to the 4th, because the a is replacing the x, times 4a to the 3rd. And then we're told in our givens that f prime of a to the 4th, well, that's equal to 11. So this really becomes 11 times 4a cubed, which simplifies to 44a to the 3rd. Okay, so we get that. Good stuff, right? For sure. Okay, now let's do the g prime of a. So now they want us to evaluate the derivative of capital G at the value a. Again, we need to first find the derivative of g. So we know that g prime of x, well here, now our outside function is something raised to the 4th power, or we could think of this as x to the 4th. So we'll take the derivative of that, but evaluate it at f of x. So that's going to give us 4 times f of x to the 3rd. And then we're going to multiply by f prime of a on the outside, because we take, or sorry, of x, because we multiply by the derivative of the inside function. Okay? Then we'll go through, evaluate this at a, so it would be g prime of a equals 4 times f of a cubed times f prime of a equals, and let's see, we have f of a is 2, and I also just noticed, sorry, on the last one we were told a cubed was 2, so we could have finished and gone a little bit further with that answer. I apologize. So f of a is 2, so this would become 4 times 2 cubed times f prime of a, we're told right here, is 15, so we have that multiplied by 15. So let's see, 4 times 2 cubed is 8, so we have 32 times 15. 32 times 15, which looks like it gives us 480 as our answer. Okay, so G prime, capital G prime of A is 480. Sweet. All right, last thing, another derivative problem that involves a little bit more complex chain rule. This is another one for your classwork assignment, so get to work on it there. Okay, thanks for watching.